Hello students and welcome to the lecture. So students, as you can see here, basically in this lecture we are going to start the discussion over the unit and dimensions. Okay, unit and dimensions is going to be a topic for the discussion and this is going to be the part 1. Alright, basically in this lecture we will first take the discussion over the introduction of the unit and dimensions, what we exactly mean by them. Secondly, we will see specifically on the unit. Then, what are the kinds of unit? Thereafter, what is the systems of unit? Then, units of length. And at last, we will see the summary of all of these. Got it? But before starting this lecture, there is a small disclaimer that we are required to understand first. The disclaimer is like the images used in a slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this tag and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. Now, first, let's begin with the introduction. So basically here we will start the discussion over the unit and dimension. But before this, in the introduction part, we will try to understand some other things that are closely associated with the units and dimensions and that we are required to understand first. Okay, so we could say the word science actually originates from the Latin word scientia, which is actually meaning to know something, to have the knowledge of something. Okay, and there is also the Sanskrit word called Vijnan and the Arabic word called ilm convey the similar meaning, namely the knowledge. So you can say there are the three different language from where we had taken a word to originate the word science. First, Latin word scientia. Second, Sanskrit word Vijnan. Third, Arabic word ilm. All these three is having a similar meaning, namely the knowledge. That you having a knowledge of something, you having the ilm of something, Vijnan of something, and scientia of something. Systematic knowledge based on the facts, on the experimentations, and observations. Facts, experimentations, and the observation. And when we talk about these things, we actually talking about the science. Like knowledge is the capacity of having some, you can say, things in your mind. But if these things are actually based on the logical facts, experimentations, and valuable observations, then these are called the science. Generally, science is mended into the three main categories. These categories are abstract science, the science which is not that much connected to anything in a particular way. Social science, that is actually connected with the society and all. And the third is natural science. Natural science is the science that is connected to the nature itself. So these are the three mandate in the science: abstract science, social science, and then the natural science. If we talk about the first one, that is the abstract science. So in a particular way, we could say the abstract science is actually the study of relationship of magnitude and numbers. Okay, like magnitude is not specifically connected to something, it is the value in itself. Similarly with the numbers, that's why it is known as the abstract science. Examples are mathematics, statistics, etc. Then social science. It is the study of social activities of man based on the traditions and reasoning. Examples that subjects covered under the social science. These examples are sociology, political science, economics, geography, and so on. Like these areas where we having the social activities of man, and these social activities based on the facts, experiments, and observation in relation with the tradition and reasoning that we have in the society or that we live by. Third one that we have as the mandate in science is the natural science. Natural science, by its name, you could conclude that it's the science of the nature. So it is actually the study of facts of the nature. It is generally also called as a basic science because it is all natural. There is nothing to be added in this. So that's why it is known as the basic science. Natural science is mandated into two fields on the basis of their nature of study. Physical science, that is actually not containing any kind of living things, but it is the science of presented and non-living things. Last one is the biological science. Biological science is a science that is actually connected with the living things and all. Okay. Now, if we take physical science into a consideration for our understanding, we could say, as I have told you right now, the study of non-living beings and the natural phenomena governed by a set of laws. Okay, like you can say, these are the non-living beings, which means these things having no life in them. If we talk about like if there is a stone which is looking grayish, okay, after a certain period of time, due to some chemical compositions and all, that grayish color have been converted into the green color. Now you can say there is a change because of the scientific facts. Okay. So is there anything that the rock did by itself? No, because the rock is not a living thing. It is a non-living thing. Okay. So what happened with the rock, like grayish to greenish? It is happening because of the natural phenomena, right? It is not the power of that rock by itself. It is a power of the nature. And that power is actually governed by the set of laws, right? Set of laws. Examples of this: physics, chemistry, astronomy, meteorology, metallurgy, and so on. Because in physics, there is no living beings involved. In chemistry, no living beings. In astronomy, no. Meteorology, no. Metallurgy, no. These all are the non-living beings. Anything that happens with them, anything they involved in it, it is all because of the natural phenomena. Opposite to this, biological science, that is the part of the natural science, is actually the study of living beings. Okay, like you can say in biological science, living beings having the lives in them, they are the one who are controlling the things by themselves in order to gaining a power from the scientific facts. Like if you can say, suppose we know the organisms replicate themselves, they reproduce themselves so that they could continue the generation, right? If there is a human beings, if we look at them, so we know human beings also reproduce themselves. If there is other kind of creature, for example, if there is a any kind of insect, okay, that insect will reproduce or replicate itself, right? So that they could generate more of their kinds. So now you can say they are changing themselves, but with these psychological means. That's why it is also called as a life science or biology, because life science is the meaning of like it is containing the life. Every fact that is the scientific fact related with the life that is comes under the life science. Biology, on the other hand, is the study of living beings, right? Science is ever dynamic. Remember this. When we talk about the laws of science, okay? So whenever we heard about them, we could say that these laws are static. Then why we are called the science is ever dynamic? Because science is the continuous study of exploration. Okay? Like if we take the example of this, we could say, suppose, have you ever heard about the atoms? For example, okay? We all know the most basic unit of any matter or anything is the atom. Alright? Then if we go by these facts like science is dynamic or static, so we could say while we were exploring the atoms, we had formulated a different kind of atomic models. First, we say as a plum pudding model came into the picture. Okay. Then you can say another models like the Niels Bohr models and all other Ford models and all. Right. So you can say when we talk about the scientific facts, they seem static because right now we have only explored the facts till there. And we are thinking that this thing that we have discovered or this thing that we have come to know about, this is the main thing. But when we continue the study with this, we will find that these facts are actually having more things to be discovered. So that's why scientific facts may look like a static facts, but these are not. These are dynamic facts. Okay. There is no final theory in science and no unquestionable authority among scientists. All right. Like you can say, first, if we talk about the gravitation, we know the gravitation is the one of the most important topic. Even we will cover in this series of science that topic. Okay. So the gravitation, if we talk about, the gravitation is a theory of science. Okay. Like every heavenly body attracts the other things because of the center of gravity at the center of that particular thing. Okay. This is the most basic theory we could say. This theory is even not final. If I say that this theory is final, I'm wrong because this theory is not. This theory also having some alternate theories with it. Okay. And there is no unquestionable authority amongst the scientists. Like you can say, suppose if there are three scientists, Mr. X, Mr. Y, Mr. Z, they are working on something. Mr. X proposed a theory that this thing is actually that thing. Okay. So it is not the way that Mr. Y and Mr. Z couldn't questionable them. They could. Okay. Because science respect and welcomes the other ideas too. In science, the approach is always open-minded in which no points of view are overlooked without the logical reasons. Okay, like no viewpoint could be discarded without giving the logical reason behind the discardation. In all fact, all theories of science have to be updated whenever required so that they are consistent with all the experimental data collected by that time. The word comes from the Greek word physis meaning the nature. Its Sanskrit equivalent is bhautiki that is used to refer to the study of physical worlds. Okay, like in Greek, we use the word physis to show the natural or nature. In Sanskrit, we use the word bhautiki to refer to the physical world. Physics, if we talk about in a particular manner, is that branch of science in which we observe, measure, and describe the natural phenomena related to matter and energy. What do you mean by matter and what do you mean by energy? We will look upon them in the upcoming lectures. Till then, just remember that in physics, which is the branch of science, we observe, then we measure, and whatever we got, we describe as the natural phenomena which is being related to the matter energy. These natural phenomena could be classified as mechanics, properties of matter, sound, light, heat, electricity, atomic physics, nuclear physics, etc. So all these natural phenomena that we have looked upon, these are the parts of physics. So first, physical quantity. The quantities by means of which we describe the laws of physics are called the physical quantities. If we talk about what is the physical quantity in actual, a physical quantity is completely specified if it is having the numerical value only. Therefore, ratio, example, refractive index, dielectric constant. Then when they having a numerical value only, not having any other kind of systematic value associated with that thing, that we called it as a physical quantity. Magnitude only, therefore scalar, mass, time, etc. Magnitude and directions both, vector, force, velocity, etc. Like you can say, when we talk about the physical quantity, basically they having the two types, scalar quantities and vector quantities. The scalar quantities are those quantities which only having the magnitude but they do not having a direction. Like the mass. Mass is just having the magnitude. If you're saying the mass is the 40 kg, then you say it's a 40 kg only. This is no direction associated with that thing. But if you say force, like 10 Newton force, then force always having some direction, right? There is an important note. These are also some such physical quantities which are not completely specified even by magnitude and direction. Okay, that's why I told you science is not absolute, it's always dynamic. Such physical quantities are called tensors, example moment of inertia. So to express large or small magnitudes simultaneously, we use the following prefix. Power, prefix, symbol, power of 10, prefix, symbol. Like 10 की power 18, prefix 18, sorry, exa, synonymal, e, power of 10, 10 in 1, prefix, deci, symbol d. 10 की power 15, prefix peta, synonymal p, power of 10, 10 of 2, prefix centi, c. 10 power 12, tera, synonymal t, 10 3, milti, m. 10 power 9, giga, g, 10 6, micro, this. 10 power 5, mega, m, 10 9, nano, n. 10 power 3, kilo, sinyball, k, 10 12, pico, p. 10 power 2, hecto, h, 10 15, femto, f. 10 power 1, deca, da, 10 16, atto, a. Got it? So now it's a time for discussing the unit. What is mean by unit actually? The reference standard of measurement of physical quantity is called the unit. Like physical quantity. Okay. Then how we should measure them? Because physical quantities are in different forms. So basically we set a standard of measurement. Okay, the standard of measurement. These standards are called the physical quantity. And these are called the unit. The unit chosen should have the following properties. First, the unit should be of convenient size. It should be possible to define the unit without ambiguity, therefore well defined. Third, the unit should be reproducible. Fourth, the value of the unit should not change with space and time. And the last three conditions are essential for the unit to be accepted internationally. Okay. There is an important note. The General Conference on Weight and Measures, French, Conference G, and URL des poids et mesures or CGPM is a supreme authority to decide the units by international agreement. Got it? This organization was actually established on 20th May 1875 and it's having its headquarters located in Savoie in France. Now, what are the kinds of unit? because now we have taken the introduction to unit. Now it's the time to take the kinds of units. So the units are of the two kinds: fundamental or basic units, then the derived units. Okay. Now the first one is the fundamental units or basic units. These we could also say these are the actual unit. A fundamental unit is that which is independent of any other unit or which could neither be changed nor can be related to any other fundamental unit. Like if we say there are two units x and y, both are independent to each other, the y having no influence on x and x not having any influence on y, these units will call fundamental units. Example of this: units of mass, length, time, temperature, current, electricity, amount of substance. These units are actually the units that are independent of each other. Okay, these are not interdependent. The mass has nothing to do with length, length nothing to do with time, time temperature, temperature current, electricity and all. That's why these are known as the fundamental units, because these are the basic or the actual units that we could say. Now the derived unit or derived units. Derived units are those which actually depend on the fundamental units or which could be expressed in terms of the fundamental units. Like you can say derived units having the dependency or expression in terms of the fundamental units. Like the speed could be related with the time, velocity could be related with the time, force, etc. These are called the derived units because they could be expressed or they could have the dependency on the fundamental or basic units. Now systems of units. In mechanics, length, mass, time. These are the three fundamental quantities. They independent of each other and all other quantities could be related with them. For the units, these three basic quantities, following system have been used. First is the CGS system, which is also known as the French system. In this system, the unit of length is actually the centimeter, cm, of mass is gram, g, and of time is seconds. This is the first. FPS system, which is also known as the British system. In this system, the unit of length is actually the foot or feet. Mass is pound, this, and that of time is seconds. Third is the MKS unit or metric system. In this system, the unit of length is meter m, mass is kilogram kg, and of time is seconds s. Got it? Later on, apart from mass, length, and time, current was also considered as the fundamental quantity. The metric system was then known as the Maxa system. Thus, in Maxa system, the unit of length in meter m, of mass is kilogram kg, of time is second s, and of current is ampere a. Note, if instead of current, charge is taken as the fundamental quantity, then the metric system is also called the MKS system, and the unit of charge is coulomb, represented by capital C. Okay. Now the international system of units, that is famously known as the SI units. So whenever you see the SI units, always remember that we are talking about the international system of units. That was in 1971. The International Bureau of Weights and Measures held its meeting and decided a system of units which is known as the International System of Units. It is abbreviated as SI unit from the French name Les Items Internationaux d'Unité. Nowadays, this system is widely used throughout the world. This system of unit is essentially a modification over the MKS system and is therefore called the rationalized MKS system. Got it? Now, the SI units are actually based on the following 7 fundamental units and 2 supplementary units which are listed in this table. If we look at this, so first is basic physical quantity or the fundamental quantities, then fundamental units and their symbols. Length, meter, symbol is small m. Mass, kilogram, symbol is small kg. Time, fundamental unit seconds, small s. Temperature, fundamental units Kelvin, capital K. Electric current, fundamental unit ampere, small a. Luminous intensity, fundamental unit candela, capital C and small d. Coon, fundamental unit mole, symbol is MON. Supplementary physical quantity, plane angle, supplementary unit radian, symbol rad. Solid angle, supplementary unit steradian, small sr. Now, the units of length, if we talk about them. In SI system, the length is measured in the unit meter. A meter was originally got defined in 1889 as the distance between the two marks drawn on a platinum iridium, an alloy with 90 platinum and 10 iridium rod, which was kept at the 0 degree Celsius in the International Bureau of Weights and Measures at Sieverts near Paris, which is in the France. And this is what we have just studied, is the main area from where the international system of units, which is oftenly called as CSI units, was derived. Later in 1960, the meter was again redefined as 1650763.73 times of the wavelength of specified orange-red spectral line in the emission spectrum of krypton 86, or 1 meter is 1553164.1 times the wavelength of the red line is the spectrum of cadmium. In 1983, again, the meter was redefined in terms of speed of light, according to which the distance traveled by light in vacuum in 1/2997992.458 second is called the watt meter. And the subunit of meter that got developed over the period of time. And the most commonly used subunits of the meters are the centimeter, cm, millimeter, mm, micron or micrometer or nanometer, nm. 1 centimeter is 10 minus 2 m, 1 mm is 10 minus 3 m, 1 lambda is 10 minus 6 m, 1 nm is 10 minus m. Multiple units of meter. The most commonly used multiple units of meter is kilometer km, and 1 kilometer is 10's power 3 meter, which is actually the 1000 meters. Non-metric units of length. The commonly used non-metric units are as follows. First is the astronomical unit, also known as AEU. One astronomical unit is equal to the mean distance between the Earth and the Sun. Therefore, 1 AV is equal to 1.496 into 10^11 m. Light year. A light year is the distance traveled by light in vacuum in 1 year. Therefore, 1 light year is equal to 9.46 into 10^15 m. Parsec. 1 parsec is actually the distance from where the semi-major axis of orbit of Earth subtends on an angle of 1 degree at the center of Sun. 1 parsec, 3.26 light year is equal to 3.08 into 10^16 m. Angstrom, it is 10 minus 10, the part of meter. 1 angstrom is equal to 10 minus 10 m. Okay, this is 10 minus 10 powers m. Fermi F, it is 10 minus 10, 15, the part of meter. 1 Fermi is 10 powers minus 15 m. Smaller and bigger units of length. Okay, this is what we have covered. So here we have finished the topic. Now it's part for summary. So we have talked about the word science originated from the Latin scientia, meaning to know, and also covering the words of Sanskrit like Vijnan, Arabic like ilm. Science is systematic knowledge which is based on facts, experiment and observation, generally divided into 3 main categories of abstract science, mathematics, statistics, social science, sociological, political science, natural science, physics, chemistry, bio. Natural science got further divided into the physical science, which is the study of non-living beings and natural phenomena, and biological science, which is the study of living beings. Science is dynamic with no final theories or unquestionable authorities, as I've told you. Might be the things looks like in static, but these are not. These are dynamic because when we explore further, the things will be divided further. The approach is one-minded and the theories must be updated as new experimental data is collected. Physics, derived from the Greek word physis, nature, involves observing, measuring, and describing the natural phenomena related to the matter and energy. Then we have talked about the physical quantities used to describe the laws of physics specified by the numerical value, magnitude, direction. Units of measurement, international system of units, length is measured in meters. Larger units include the kilometers, astronomical units, light years, parsecs, angstrom, and fermis. And the SI units ensure the uniformity, precision in scientific measures globally. With this, we have finished this topic or this part 1. It is requested to all of you kindly revise the facts and figures that we have discussed in this lecture and keep yourself ready for the next lecture. With this note, let's end this lecture and thank you.